Okay, so the first kind of problem on this assessment is solving equations. We're looking for all of the solutions between 0 and 2 pi. That's what this little inequality thing there says. So what we need to do is we need to get x by itself. First, let's multiply both sides by 2. We're going to get cosine of 2x equals the square root of 2 over 2. Now, this is nice because this is a spot on the unit circle. So if I'm thinking about the unit circle, I'm looking at, okay, well, where are the x values equal to root 2 over 2? And so that's this spot right here. And it is here. So this is a little bit funky, but now we're looking at where these x values are this number. The thing that we need to be careful of is just because there's a b here, there's a number next to the x, we might have to go another rotation around the unit circle just to get all of the solutions. So this angle right here is pi over 4. This is 7 pi over 4. And so let's just make sure we include all of them. So there's going to be, let's say, 2x equals pi over 4. Let's try 7 pi over 4. Let's try another 2 pi past this one would be 9 pi over 4. And then another 2 pi past this one would be 15 pi over 4. Okay, so then if we divide everything by 2 here, so we're going to divide by 2, we're going to get x equals, okay, so pi over 8, we could have 7 pi over 8, we'd have 9 pi over 8, and then we'd have 15 pi over 8. The question is this all of the ones next within the range 0 to 2 pi? Because all of these are within 0 and 2 pi. They're all in that range. If we think about if we went another whole circle past this one, we would end up with 17 pi over 4, another 2 pi past that. So that one, if we divided it by 2, we would end up with 17 pi over 8, which is actually past 2 pi. So we can exclude that one. Anything on this side would be negative, and so that would exclude all of those also. So our answers are just these 4. I would definitely recommend that I go to the graph and check my work here. So I would type in y equals 1/2 cosine of 2x, and then I would type in y equals square root 2 over 4. And then I might put in 0 is less than or equal to x is less than or equal to 2 pi, because that's the rule that it says right here. I would put in all 3 of these in Desmos, 1, 2, and 3. And then I'm looking for all the places where this graph crosses this graph. And there should be 4 of them, and it should be these 4 values. We're looking for the x values. So you can check your work by doing that. Or you can do this problem by just using the graph. So you can start right here and do these 3 things and send me a screenshot of that on your assessment. And that's totally fine with me as a method for you to solve these problems. Let's do this one. This one is a little bit trickier because we're working with tangent. And so working with tangent is just a little bit more annoying because we have to think about both sine and cosine then. Okay, so we have tangent of x minus 2 pi over 3 equals negative root 3. Okay, so then we're looking for the values, the angles on the unit circle where the tangent is equal to negative root 3. The 2 spots on the unit circle for that are here and here. I know my unit circle is really bad in this diagram, but this is the spot. This must be 2 pi over 3, and this one must be 5 pi over 3. Okay, so the one thing that I see here is that we're going to be adding a 2 pi over 3 to get to our answer. So I think I should actually just go at least one more rotation in each direction. So this angle coterminal, a whole nother 2 pi would be, so we have we have x minus 2 pi over 3 equals, okay, so we had our 2 pi over 3, we had our 5 pi over 3. Let's go one more rotation around. So that would be 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. If we go another rotation around from this one, we'd end up with 11 pi over 3. If we go a rotation past this one on the other way, so instead of going this way, we might go this way. That would give us negative 5 pi over 3. And then this one right here would be negative pi over 3. So I know that I've kind of put a bunch more options in this list, but that's because I know that I'm going to be adding a 2 pi over 3, which might make me one of my negative answers become positive. So let's add a 2 pi over 3 to both sides to get x by itself. So we're going to take all of these options and add a 2 pi over 3. Okay, so we end up with x equals. So this would be, okay, so we'd have our 2 pi over 3 plus 2 pi over 3 is 4 pi over 3. 5 pi over 3 plus 2 pi over 3 is 7 pi over 3. 8 pi over 3 plus 2 pi over 3 is 10 pi over 3. 11 pi over 3 plus 2 pi over 3 is 14 pi over 3. And then we'd have this one, so we'd have our negative 5 pi over 3 would be plus 2 pi over 3 is negative 3 pi over 3. And then we'd have negative pi over 3 plus 2 pi over 3 is pi over 3. Okay, so which ones of these are within our range of 0 to 2 pi? Well, only this one and this one. This is bigger than 2 pi, this is bigger than 2 pi, this is bigger than 2 pi. This is smaller than 0 over, yeah, smaller than 0. So the only answers that we have here are x equals 4 pi over 3 and pi over 3. You can again check this by putting in y equals tangent of x minus 2 pi over 3, and then y equals, you know what, we should do it this way. We should say plus root 3, sorry I missed that part, and then we should say y equals 0. And then we're looking for the range between 0 is less than or equal to x is less than or equal to 2 pi. So you can put these three things into Desmos and see where these two cross within this range. So you should get two answers. Here they are. And we're looking for the x values again. Okay, that's it. This is the summary slide that you're going to be able to use on the assessment. It's already linked on, there's already a screenshot of this basically on the assessment, and so you can just use this. So we'll use that while we go through our problems for the rest of this.
For these types of problems,
what I'm looking for is I'm looking for you to find the part of the equation that shows you each characteristic of the graph, and then tell me what that means in terms of what the graph looks like. So, for example, here's an equation that says negative 2 times the tangent of x plus pi over 8 minus 12. So let's start with the period of the function. And remember that the period is in this spot right here. There's usually a b right here. B is written with nothing there, so we can assume that it's 1. Normally, our tangent has period pi over b, so remember that that one is different from cosine and sine. Sine and cosine have 2 pi over b, but we're given that tangent is pi over b. So if b is 1, then our period is pi over 1, which is just pi. So that means that this graph repeats every pi units, and you can check that on the graph by just looking from asymptote to asymptote. So there's one, and that is pi units. You can see that there. Great. Okay, the midline, we're going to look at our k, and our k here is negative 12, so that means that our midline is at y equals negative 12. We have a phase shift here. We're looking for our h. H is going to be negative pi over 8. So that means that that's a translation left pi over 8 units. On the assessment, you would select this section and then bold it to make sure that you can show me that you know that it's a translation left. Translations, remember, are called phase shifts if it's left and right. Okay, let's look at A. A is negative which means that we do have a reflection across the x-axis. And then B is positive, so then we do not have a reflection across the y-axis. This is what I'm looking for you to do. Remember that if it has this slash here, that means that you have to choose one and then bold it. So just highlight and then choose the B on the top bar, or you can do Control B or Apple B depending on whatever your device is. Here's a cosine graph. We're going to do the same exact stuff, except we have to remember that the period of a cosine graph is cosine is 2 pi over b. So if b is this pi over 9, then our cosine, the period has cosine, or the cosine has period 2 pi over pi over 9. So this is the tricky thing, because remember that we have to take this and rewrite it as 2 pi times the reciprocal, 9 over pi, which means that we get 18 as our period. And we can see that on the graph because from top to top, or maximum to maximum, this distance is 18 units. So this is the period. The amplitude is the number out front. For this one, it would be 1. So the amplitude is 1. The midline is if there's a plus k out here, but I see that there's nothing written there, so k is 0. The midline is y equals 0. There's also no phase shift here. We would have to have a plus or a minus h here. And so h is 0, and so then we have a no phase shift. A is 1, which is positive, so there is not a reflection. And then B is positive, so there is not a reflection. Similar story on this one. This one just has a little bit more stuff going on in it, so that's okay. Let's pay attention to the phase shift here first. So remember that sine has period 2 pi over b. And so our b is -4, so our period is 2 pi over, I guess, -4, which would be negative pi over 2. The thing about period, though, is that it's a distance, and so we can just erase this negative. So our period is pi over 2. We can see that that happens because right here to right here is one repetition of the sine graph, and we can see that it happens in pi over 2 units. The amplitude is whatever A is. A is 1/2, so amplitude is 1/2. If that number is negative, the amplitude is still a positive number, so that's why there's absolute value bars around that function, around that formula. This is 1/2 of a unit. Okay, the midline is whatever k is. I see that there's no k here, so we would have a y equals 0 as the midline. H is different on this one, and so h says minus pi. So this says -4x minus h. And so since it says minus h, this minus makes this pi a positive number, and so the positive is there. So that means that we're translating right pi units. So that just means that we took the original pi sine graph and moved it over pi units. So it would have been, the new one is right here then. Kind of like that. Okay. Reflections across the x-axis. So is A a positive number? Well, yeah, A is positive. So no, we do not have a reflection there. However, this is weird. We have a reflection across the y-axis because B is negative. So pay attention to that. If anything is negative, that means that you do have a reflection. If anything is positive, that means you do not. Okay, so just pay attention to that. That's all you need to do on the assessment, and then you are officially done for this quarter. Nice work, everybody.